Okay, we're in 2.6, logarithmic functions. And before we jump into talking about the log functions, first we'll learn about inverse functions. So that's going to be the first goal for this section. So another type of function we'll be studying is called the logarithmic function again. And there's a close connection between log functions and exponential functions that we talked about in the previous section. We'll see that the log functions and exponential functions are inverse functions of each other. Okay, that's how they're related. We will study that concept of inverse functions as a prerequisite for the study of log functions. So let's focus in on that first. Okay, and well, before we define the inverse of a function, we need to focus on another topic, and that's the topic of a one-to-one function in mathematics. So let's see what functions are considered one-to-one. And it's not all of them, only certain functions in math are one-to-one. So in fact, the function f is said to be one-to-one if each range value corresponds to exactly one domain value. Read that again. If each range value, in other words, if each output corresponds to exactly one input domain value. Okay, so this is the graph of a one-to-one function as an example. Notice that if we choose two different x values, the corresponding y values are different. So if I pick 0 and 1, the corresponding y values are going to be different here. Okay, so if x is 0, then y is 1. And if x is 1, then y is about 2.8. Okay, so we have 1, 2.8, and 0, 1. Okay, now choose any other pair of x values. Okay, so if we choose maybe -1 and 2. Okay, do you see that the corresponding y values will always be different? And the answer should be yes, because of this curve, right? Whatever the value here is, maybe 0.5, it's going to differ from what it is at 2, which we can't even see on this window. Okay, so recall that for an equation to be a function, its graph must pass what we call the vertical line test. That is, a vertical line that sweeps across the graph of a function from left to right will intersect the graph only once at each x value. Remember, if we had some curve here, for it to be a function, it had to pass this vertical line test. Anywhere you pass a vertical line, it can only hit the graph of this function once. Well, there's a similar geometric test to determine if a function is one-to-one, and it's called the horizontal line test. Okay, so any horizontal line drawn through the graph of a one-to-one function will cross the graph only once. If a horizontal line crosses a graph more than once, then the function that is graphed is not one-to-one. So here's some graph to determine if the graph of this function is one-to-one. We pass horizontal lines throughout, and if these horizontal lines hit our graph more than once, well, then this graph is not the graph of a one-to-one function. However, notice they only hit once anywhere, so that means this function is one-to-one. Why don't we take a look at some other examples here. How about this function on the left? Is this one-to-one? Well, the answer is yes, because if I pass a horizontal line through my graph, it's going to hit at most once. Even over here at the bottom, it might seem like it doesn't, but it only hits once at one place only. Okay, if you look at the parabola on the other hand, this function is not one-to-one because this horizontal line that I just drew intersected my graph twice at two different points. Okay, so this is not one-to-one. This graph was one-to-one. Okay, so now that we know what a one-to-one function is, we could say if f is a one-to-one function, then the inverse of f is the function formed by interchanging the independent and dependent variable for f, the x and the y. Thus, if a comma b is a point on the graph of f, we simply interchange those x and y coordinates. B comma a is a point on the graph of the inverse of f. Okay, and the inverse of f is oftentimes denoted f inverse like this. We have a -1, which looks like a power, but it's not an exponent. It's not a power. This just means inverse function. Okay, inverse of f. Okay, so right away that means that if a function is not one-to-one, in other words, it fails the horizontal line test, then f does not have an inverse.